Hello, my name is Madam Jennifer from Educare TZ. Welcome again, my Form 3 students, in our lovely subject chemistry, and we are proceeding with our topic known as chemical kinetics, equilibrium, and energetic. And today's session will discuss our last subtopic. We have already discussed on the first subtopic, the rate of chemical reaction. We have already seen the factor affecting the rate of chemical reaction, reversible and irreversible reaction. We have already discussed also on this chemical industrial process. Also, we have already discussed the chemical equilibrium. And now we finalize our topic by covering this subtopic known as chemical energetic. The chemical energetic, the study of energy change that accompany the chemical reaction is called electrochemistry. The study of chemical change, the change in chemical process in a chemical reaction inaitwa electrochemistry. Now, molecules have energy due to vibration and rotational motion of particles that make them. As molecules zinapokuwa zina move from one place to another, they tend to collide and exchange energy through vibration and rotational energy. Also, the potential energy, this molecule also possesses this molecule possesses some amount of energy due to their position, and this is called potential energy. Now, there are also a kind of energy which is possessed by the molecule, and the first one is intermolecular energy. Intermolecular comes from the term intra. Intra means within. Within what? Within the same molecule. So, intermolecular energy is the potential energy stored in a molecule due to their position that exists within the same molecule. So, the potential energy stored within the molecule due to their position is the one which is called intermolecular energy. The vice versa too, energy which is stored between the molecule of the different compound is called intermolecular energy. In other words, intermolecular energy is the energy which exists between different molecule. Example is hydrogen bond. Kwa katika bondi ya maji, hydrogen, katika maji tuna hydrogen na pia tuna oxygen. Wawili katika maji, kiandika symbol ya maji, hydrogen wawili na oxygen moja. So bond which exists between hydrogen and hydrogen, ile ni intermolecular energy. Lakini the bond which exists between hydrogen na oxygen, ile pale ni intermolecular energy because it exists between hydrogen and the oxygen. And that bond which is between hydrogen and oxygen tunaita hydrogen bond. Now, heat enthalpy or content. What is heat enthalpy? Heat enthalpy means the change of something. So, heat enthalpy is a sum of kinetic energy and potential energy of the substance. So, the energy due to vibration or rotational in a molecule and energy due to the position of molecule or potential energy of a substance, which is called the heat enthalpy or heat content. And the unit of this heat enthalpy is H, na unit yake ni joule. Kwa unit of heat ni joule. Na chemical reaction involve rearrangement of atom and molecule. Means that chemical reaction involve the breaking of the bond and formation of the new bond. Breaking of the bond of the reactant and formation of the new bond of product. Now, enthalpy change. Enthalpy change is the difference between energy released and energy absorbed in a reaction. The energy released, this is energy come from the breaking of the bond of the reactant, and energy absorbed is energy which is due to the formation of products. Now, enthalpy change in a chemical reaction. Enthalpy change in a chemical reaction is the energy gained or lost during chemical reaction carried out at constant pressure. Kwa pressure lazima iwe constant. Energy inapokuwa energy gained due to the formation of product, and the energy is lost due to the breaking of the bond of the reactant in a chemical reaction and carried at a constant pressure. And it is represented by symbol change H. Hii hapa symbol AH, hii ya triangle inaonyesha change, na hii hapa H hapa ni heat. Kwa hiyo inaonyesha enthalpy change. And the unit, the SI unit is kilogram per joule, kwa kifupi unaweza kuandika kilojoule per mole. Kwa hapa ni SI unit ya heat change, na SI unit ya heat tumesema ni joule. So kama kuna heat change hapa tunakuwa kuna kilojoule per mole. Now the enthalpy in a chemical reaction, in other words you can say, is the difference between heat content of the reactant and that of the product. Kwa ni utofauti kati ya heat ya reactant na ile ya product, na it is represented that heat change sasa na heat content of product minus heat content of reactant. Kwa kifupi unaweza kuandika heat change sasa na heat change ya product minus heat change of reactant. Don't forget to write the SI units unapokuwa unaandika jibu lako. Now, the value of AH is shown at the end of the reaction. Kwa value ya heat change ndio hapa AX inaonyeshwa baada ya nini? At the end of the chemical reaction, hapa tuna reaction A na B hapa reactant, and C and D hapa ni product formed after the rearrangement or breaking of the bond of A and B to form new product C and D, and the heat change is Xc kilojoule per mole, and this Xc indicates the value of AH. Now thermochemical equation. Thermochemical, hapo tunaona kuna temperature. Thermo come from the term temperature, so means that that's a chemical equation that include the enthalpy change of a reaction. So thermochemical equation ni ile equation ambayo inaonyesha enthalpy change katika reaction yako. Now let us consider this thermochemical equation. We have endothermic and exothermic reaction. Endo and exothermic also we have already discussed in our previous session that endothermic reaction are those reactions which the reaction which absorb heat from the surrounding, while the exothermic reaction are the reaction which give off heat to the surrounding. Now, the energy change occur in some physical process also. Example, the process such as solid or ice melt into water or liquid. Kwa hiyo energy change na penyewe inaweza katoka in different physical process. Kwa mfano change in solid, kwa mfano barafu yako pale inapokuwa inayuka kwenda katika liquid kutengeneza maji, ile pia ni nini? Ni energy change. Kwa pale umekuwa broke bond iliyokuwepo katika solid form na kuweza kutengeneza new product ambayo ni liquid. So it is all about the change in chemical reaction or change in energy in a chemical reaction. In every chemical reaction, reactants converted into product through chemical reaction. Now, endothermic reaction is the reaction which absorbs or uses more energy that it releases. Kwa ni ile reaction ambayo inakuwa inaabsorb kiasi kubwa cha energy kuliko kile ambacho kinakuwa kinatoka. Consider this reaction na reactants A na B wanatengeneza product C and D. If the sum of heat content of reactants A na B is less, ni ndogo kuliko sum ya product of C and D, reaction inakuwa endothermic. In other words, in endothermic reaction, the heat content of product is greater than the heat content of the reactant. Now, for endothermic reaction, the enthalpy of product is greater than the enthalpy of HR, which means the enthalpy of reactant. Now, therefore, the value of heat change inakuwa ni positive kwa sababu heat is absorbed. Kwa kuna kiasi ambacho kinakuwa kinapotea. So long as you gain something, inakuwa ni positive faida. That's why it is positive. This shows that heat is gained in a reaction mixture. Example of endothermic reaction, we have photosynthesis process. Tuna photosynthesis process example, we have thermal decomposition of calcium carbonate. These are example of the endothermic reaction. All tunaona kwamba energy is being gained during the chemical reaction. And this is an energy profile diagram for endothermic reaction. Tumeona kuwa product, ukiangalia kwenye diagram product heat enthalpy ya product ni kubwa kuliko heat enthalpy ya reactant wako. That is endothermic reaction. And when you draw the graph, you have to consider these two things. In endothermic reaction, the heat enthalpy of product is greater than that of the reactant, as shown here. Product yuko chini while product wetu wapo juu. Now, exothermic reaction. This is a reaction in which heat is lost from the reaction mixture. Because the reaction which release heat to the surrounding. The energy is usually transferred as heat energy, causing the reaction mixture and the surrounding become hotter. Kwa mfano unapokuwa na perform hata titration process yako, umesoma katika volumetric analysis between alkali na base yako, assume they are strong. Unaona unapokuwa na perform titration, kuna ile flask yako ina change inakuwa ya moto. Kwa na perform titration process katika maabara, ile chombo chako kile ambacho imehold zile content zinazokuwa zina react inakuwa ya moto. This means that reaction is exothermic. Kwa inasababisha zile parallel reaction mixtures zinakuwa za moto. Means that the heat is given out to the surrounding. Now, for exothermic reaction, the heat enthalpy of reactant is greater than the heat enthalpy of product. Therefore, the value of enthalpy change is negative for exothermic reaction. The example of exothermic reaction, tuna combustion reaction. Combustion reaction, vile vile kuna respiration reaction na neutralization reaction. Is the reaction between alkali and base. Respiration process respiration process katika oxidation ya glucose kutengeneza carbon dioxide and water in the presence of oxygen, or in absence tengeneza ina release ATP. Katika anaerobic respiration to release ATP either in plant inakuwa ina release ethyl alcohol, carbon dioxide na ATP. Lakini kwa animal tunapoona pale kuna pyruvic acid, lactic acid and ATP. So that indicate that the heat is being released to the surrounding. Now let us see the energy profile diagram of exothermic reaction. In exothermic reaction, we have said that the heat enthalpy, angalia hapa, the heat enthalpy of reactant is greater than the heat enthalpy of reactant. Kwa ukichukua pale kafaa yako ya heat change ambayo ni heat enthalpy ya product minus heat enthalpy of reactant, unaenda kukuta jibu na kuja kuwa negative. So that negative indicate that the reaction is exothermic. Now, endothermic and exothermic reaction, the reversible reaction are both endothermic and exothermic. Katika reversible reaction sema kama ni reaction ambayo ina proceed in both direction, forward and backward. So katika hapa reversible reaction is both endothermic and exothermic. If forward reaction ni endothermic, the backward reaction will be exothermic. Now, the magnitude of heat change for two remain the same. Kwa heat change ita remain the same, lakini ambacho kitabadilika ni sign. If the forward reaction is endothermic, the sign will be positive. But if forward reaction is exothermic, the enthalpy change pale itakuwa na negative sign, lakini the magnitude of heat change itabaki ni ile ile. Kama ni 20 itabaki ni 20. Now, my students, we have already discussed on the concept of energetic. We have discussed on different terms, example, exothermical, electrochemical reaction, potential energy, different chemical energy, example, intermolecular energy and intermolecular. We have already discussed on the enthalpy change. We have seen on how to calculate the enthalpy change in a reaction. Also, we have seen on the thermochemical equation on endothermical and exothermic reaction, and already seen also the energy profile for both thermochemical equation, endothermic and exothermic. We have already seen the difference also between the two, that the endothermic reaction, in endothermic reaction, the heat content of product is higher than that of the reactants, while in exothermic reaction, the heat content of reactant is higher than that of the product. And in endothermic reaction, the heat is gained from the surrounding, and in isothermic reaction, the heat is lost to the surrounding. Now, here there is a test for you, my students. You have to check your understanding, and also you have to pass through the content so as to improve your understanding, to improve your competence level. And the following are the thermochemical equation. Here you have given the solid carbon is oxidized to form the carbon dioxide, and the heat change here is negative 53.2 kJ per mole. And B, umepewa 2 carbon as a solid plus hydrogen as a gas, unatengeneza ethane, unatengeneza ethini. Heat change ni 53.2 kJ per mole. Now the question, explain whether the reaction isothermic and endothermic. And you have to give the reason why. And Roman 2, draw energy level diagram for each of the reaction. My student, up to there, that's mark the end of our topic. You are mostly welcome for following Educare TZ for other coming session for more competence. Have a nice day.
Purchase your tracks today.